Let's understand how to derive position time relation S is equal to ut plus half at square by graphical method using velocity time graph. So from the beginning children, first draw the graph, draw two axes, x-axis and y-axis. This is our x-axis, this one is y-axis. X-axis we represent time, y-axis we represent velocity. Okay, now this VT graph is an uniform accelerated graph. Means we start that initially our object is at point A. This is your origin point, so you're not supposed to start with the origin because there is some initial velocity u in our equation. So we suppose our object start with point A, it will take time t and come to point B finally. So from A to B it will take t second. Now where we have to represent? We have to represent this t second on the x-axis. So draw one perpendicular line here on the x-axis, give a name C. This OC is t. Okay. Now at point B it acquires its final velocity v. So final velocity from O to A there is initial velocity u. Now from B the object has its final velocity v. To represent that, again you have to draw one perpendicular line to the velocity axis. Now give the name d. So from O to D, this one is the final velocity. Okay. Now draw one perpendicular line from A to this line BC, give a name E. This is your graph. X-axis, y-axis, time and velocity. Object starts moving with point A. This OA is initial velocity u. In t second it acquire a final velocity v at point B. We represent the time on time axis and velocity on the velocity axis. Now we start the proving derivation. To derive this equation you have to start that how much distance is travelled by the object. This distance travelled by the object is actually the area under this line AB. Now line AB you have to see what area it is. So it is area of OABEC. If you look properly, this area OABEC, this is looks like this. This is this diagram. So what kind of diagram is this? This is a trapezium. In your mathematics, I hope you should know about this. So this is the area of trapezium OABEC. Okay. Now to derive the second equation, we have to segregate this area in these two mathematical shape, these two geometrical shape. This is your rectangular shape and this is a triangle shape. So just write down area of OABEC is equal to area of rectangle OAEC. First rectangle, area of rectangle OAEC plus area of this triangle ABE. Area of triangle ABE. Now write down the mathematical formula of the area of rectangle and area of triangle. Area of rectangle is what? Length into breadth, L into B, plus area of triangle is what? Half base into height. Now you have to identify what is length, what is breadth, what is height in this graph. So first you focus on the rectangle OAEC, this part. What is the length children? OC. OC is the length. OC into breadth OA plus half. Come to the triangle part. This triangle part. Base AE and height BE. AE into BE. Now put the values here. Length OC is T. OA is U plus 1 by 2. AE. What is the value of AE? If this is a rectangle, this part is T, then this part is also T. If this part is U, then EC is also U. Okay. So in the place of AE we can write down T into BE. You have to think about the value of BE. To find this value, come to this y-axis. Okay. This BE is equal to this part AD. So how can you calculate the value of AD? From O, from the origin to point D it is V, and from O to A it is U. So you can minus V minus U, then you will get this value. So it will be v minus u. The same value will be here. It is v minus u. So in place of be, put v minus u. Okay. Now from the first equation of motion, what was the first equation? V is equal to u plus at. This equation was our first equation. So put the value of v in this case. Okay. Then see what we get. We get s is equal to, just multiply t into u, write down ut plus half t. Now in bracket, in place of v, I will write u plus at and minus u. So the u plus and minus, it will cancel. This at is multiplied with this t and we get our required equation ut plus half at square. Thank you.